I'm Chad Sakach. I'm Mr. VMware at EMC.
And I'm Vaughn Stewart, Mr. VMware at NetApp, I guess.
So I guess a quick little preamble. As Vaughn and I were working on this content, the two things that kind of came to mind was, number one, we wanted to make this very vendor neutrally, right? So this is a session that we wanted to make apply to everybody.
Everyone.
So even folks that are storage vendors who aren't here.
Very in the same vein that we've done some of our best practices around iSCSI and NFS in the past, where we've come together with HP and our friends at HP and Dell, et cetera.
Yep. So generally people found that was useful, right? To find out what's common, what are common best practices, because a lot of people have mixed environments, people's environments change. No one can just be an expert on one thing, right? And the focus here, frankly, is VMware, not any one of us.
Right.
The other thing that came to mind was, holy smokes, we got way too much content.
Got a lot of slides, folks.
So what we needed to do is we needed to make some extremely hard decisions over stuff to cut, right? So we cut out like almost all of look at the cool stuff that EMC can do with VMware, and let's cut out all the cool stuff that NetApp can do with VMware, and cut out all that. We also needed to make cuts on like core content. So this is really the core of the key things that we think everybody kind of needs to know and
foundational blocking and tackling.
Exactly.
Tackling, right? So and as you'll see as we'll go through this, we're going to kind of keep the pace kind of crisp. This by no means is the be-all, end-all of the session. We'll provide you links and references to all the very detailed documents as we go through this slide deck.
So without further ado, Skip. Well, by the way, one thing that's worth pointing out, both of us author blogs. It's a good way to have an ongoing dialogue with us, right? So if you have a question, there's good stuff already on there, and if you can't, grab us, you can grab us, in fact, virtually, right?
Yeah, the one thing I would say, by show of hands, if you don't mind real quick before you start, who here follows either one of our blogs, by show of hands? Well, first and foremost, thank you for the readership.
Thank you.
Hopefully you're finding that it's informative. Hopefully you're seeing us be able to provide you information on a faster basis than what it would take through a traditional channel. So if you want to kind of keep a finger on the pulse with where we're going, it's a really good way to stay in the loop.
Totally. Skip agenda. So, has anyone here ever had a bad storage outage? Show of hands. Yeah.
Oh.
So when you have a storage outage, it's really bad, right? It's really bad for a couple reasons. Hey, look, all advanced VMware features depend on the shared storage infrastructure, which means HA is not going to save you when you have a storage outage, right? The other things that are important is as the workloads increase, as people move through those phases that you saw in, kind of consistently throughout a lot of decks of virtualizing the craplication phases, right? Virtualizing the stuff that IT controls, simple, light, things that were one-use servers that you use the internal storage and maybe you never backed up, all the way through now to people virtualizing huge I/O workloads, mission-critical applications. The pressure on the storage subsystem underneath VMware increases. The other thing is that there's a distinct relationship between performance and availability. It is an outage, effectively, if performance is bad enough, right? Really, really bad performance equals, in some cases, guest timeout and at the very least, SLAs being busted. The other thing that's interesting is that, if configuring the storage for a single ESX host is hard, larger clusters just get harder and more error prone unless it's automated. We're not going to talk about how we can automate it, but, when you have more and more clusters, this challenge becomes harder and harder. And what if you've got boatloads of clusters? And what's the relationship, with any sort of storage connectivity problem, whether it's planned or unplanned? It can be extremely severe, right? So just another quick question. By a show of hands, who here would call themselves a storage administrator, whether they're also the VMware administrator?
You were reading my mind. That was great.
Come on, you and I are like brothers from another mother.
That's right.
So there's a linkage increasingly that sometimes it's actually the same dude, right, who's doing both jobs. But sometimes even when it's not, the storage teams and the VMware teams have got to be very, very close. And sometimes that's friendly, and sometimes, it's not as close as it should be, and there's like these walls of silo between them, right? That causes, at least in I think we were talking about it before, in our experience, a lot of problems. And it's related to this stuff here. So, let's start getting into these practical questions.
Absolutely.
So this session is going to cover everything. It's going to cover, NAS models, iSCSI models, other types of block models. But inevitably, both of us tend to get a lot of questions of like, what's the right protocol, right? In general, at this point, there's pretty consistent core VMware functionality across protocol types, right? Yes, periodically there's something that's marginally ahead for 6 months. Sometimes there's stuff that you can innovate at the storage layer before you can innovate it at the VMware layer. Sometimes prioritization for features mean that it comes on one protocol versus another. But by and large, the stuff that keeps the lights on and make VMware environments work well can work on almost any protocol type.
I think there's also a second way to look at it, which is there's always going to be, while VMware is much better today with consistency of delivering innovation across all protocols, there's always going to be some time where that's not going to always be possible, and you're going to have VMware delivering feature sets, and there may be splits in terms of version 1, version 2, 6 months, 12 months apart. Mm-hmm. But you also have the other aspect of it, which is your storage vendor will be delivering integration points as well, and those may not always be on par as well. Mm-hmm. May have a feature on NAS versus SAN, or SAN versus NAS in terms of which comes to delivery or to market first. Mm-hmm. So it's kind of if you're looking at it just as what does VMware give me, that may not be the right way to look at it. You may need to take the extra step further and say, well, what is my vendor? What is HP or Dell or EMC or NetApp providing for me, and how does that help me tackle my business challenges?
Exactly. So one thing that we thought would be fun on this is actually look at some data. So this is the first sample set.
So this data is this is actual data as of July 2009. Rob, I hope you're covering your ears in this. This comes from NetApp's auto support. These are actual data points coming back from actual production systems in the real world. And so this is our protocol mix. And so as you can see here, from between all three protocols, we are all within 10% of each other. Okay, so it's a very even and balanced mix. And actually, just under 11% of our systems leverage multiple protocols.
So one other thing, I don't know whether anyone here actually contributed, but I did a survey on Virtual Geek, right, that actually asked the question, and there was 800 respondents in total. Only 125 completed all the questions. For those of you that did them, thank you. And one of the questions is, what protocol are you using? And now, the Virtual Geek readership, is probably slightly more biased towards EMC, but it also actually is boatloads of people who have nothing to do with EMC storage, right, and have stuff from all over the place. So it's, kind of a horizontal industry-wide look. And this is the breakdown. So, again, you can see that a lot of mix of different protocol types. And the one thing that I thought was the most interesting is I sliced it again, and I sliced it and said, how many people, excluding DAS, said I'm using more than one? And if you take a look, 60% of the respondents on Virtual Geek said I'm using more than one. So there's one big takeaway conclusion on this. Don't sweat it. Pick what works for you, right? We find that the best flexibility comes from being able to have a mix of block and VMFS models along with NFS models. We think that, frankly, more and more the industry is going to move towards models where, you have the flexibility of protocol choice.
Really, the determining factor today should be, obviously, one, if there's a business challenge, an operational challenge, or something along that line that you need to address, that's always something that you're going to consider, and you may need to change an architecture for. But if you're not in that model and you're looking just to build your architecture, maybe a new generation, a hardware refresh, it's really, what's your storage network? If you have fiber channel, then go down the VMFS path. If you have Ethernet, then you're going to have options in front of you. Work with your storage vendor to pick and choose where you should be putting what types of application sets where. I think we're in agreement on this, which is when it comes to how we should be building our infrastructures, we have knowledge, but we're going to rely on our counterparts at Cisco to give us the best guidance in building out a network. We're going to rely on our counterparts at VMware for the hypervisor and the management layer. We'd like to be looked at as where the buck stops here in terms of delivering I/O for an application set.
Right. The other thing that's very important is it's not just what you have, but in terms of the kit, but what is in people's brains, right? So if you have a lot of Ethernet expertise, like the people who are going to do it, then that's going to make you more likely to succeed,
Absolutely.
Right? So, think of it that way as opposed to getting into the check mark, kind of sequence of things that often people want to debate furiously over, at least to me, what seems to be nits. So, why don't you talk about this one?
Yeah, so I actually may have spoke ahead of the slides a bit. So VMware has their key documents around storage, right? So we've listed here the Fiber Channel SAN configuration guides as well as the iSCSI and the SAN compatibility guides. So these are critical documents for you to review and implement in your environment. There are going to be points and times where things are stated as being supported and things are stated as not being supported. Okay? Please stay within the supported side. You will get the best experience, even if it's maybe cause you some grief because you want to get ahead of the curve. Stay within the supported parameters. Okay? And again, when it comes to working with a multiple number of vendors.
Your voice is totally going.
Yeah, I know.
I wonder what you were doing last night.
Yeah. When it comes to working with multiple vendors, there it goes. I'm actually hitting puberty right now. We've published multiple documents stating our best practices. And again, when working with multiple vendors, the folks from Dell or HP or EMC or NetApp Storage who are helping you, they should be considered the experts when it comes to this part of the architecture.
So I put at the top, this is highly recommended, but that's my Canadian-friendly way of saying mandatory, right? So consider it, don't have to kill the tree. You can read it on your iPad if you'd like, but they're authoritative. We try pretty hard also to do refreshes of these, on a pretty frequent basis. Like sometimes it's every quarter, sometimes it's every 2 quarters. We try our best to be synchronous with major VMware changes. The one thing I would highlight is in the same way that it's starting to become like, hey, look, if you don't have a vCenter plugin, like, what are you doing?
Yep.
If your vendor doesn't have a really good support doc for VMware, push them a little bit because, these are in effect the Bibles for the storage arrays.
Yeah, I mean, just real brief, we updated our best practice book within 30 days of the release of vSphere 4.1, right? So it included all the new capabilities with VAI and SIOC, etc. We also have been taking steps to simplify, so driving automation and operational expense savings through automation, and automation meaning plugins, right? So we've started to take out the manual coordinated efforts between a VI admin and a storage admin types of functions and replace it with scripts in the docs. In the last version of our doc, we reduced the document size by 26%. But I mean, these are substantial documents. I think our doc is still like 94 pages.
So the last thing that I also wanted to highlight on this, right, is sometimes people who didn't come from the storage industry and are being introduced to it as the VMware admins, sometimes it's a very foreign concept. The storage arrays vary so much architecturally. Yes. It's not like server variation, which there's variation between servers, but it's in a narrower band. The storage arrays are so different that direct comparisons and sharing of best practices is tricky. Now we have distilled out the ones that are shared, so let's hit it into those.
So I'll take this one.
Yeah, go for it.
So just by a show of hands, how many of you in the audience are familiar with the concept of virtual machine misalignment or file system misalignment? Good. I'm glad to see that the word is getting out. I'm going to give you just a real brief example of what this means. And hopefully you are going to take this information and take it back in-house if you have not already implemented these best practices. What I have here on the screen is the bottom row is a blue row showing chunks. These are chunks in terms of what a storage controller breaks up in terms of data boundaries, in terms of what the allocation units it's going to read or write at. And these can be as small as 4K on something like a NetApp box, could be as large as 64K on like a Symmetrix, right?
Yeah. So the thing that I think it's important to understand is this is an artifact of RAID, right? And notice that what we're talking about here applies to every array.
Yep.
The amount of the impact that you get out of alignment varies based on array, it varies based on your use cases, but it affects us all, and it affects every protocol and every use case.
And this is not a new issue by any means. This is actually an old SAN issue, right? We all went through this a decade ago, for those of you who aren't in the storage space. You used to ask, right, in the early days of SAN, if you were going to deploy a Solaris system on SAN, you'd have to get down with some tools, boot up your box, and do some manual configuration of your partitions before you installed, say, Solaris, right? So what we have here on the second row, the gray row, is a larger block size, maybe 1 to 8 megabytes, because it's a VMFS block. And it is possible back from the old VI30 days.
And some people actually still do it via the CLI. If you do it in the CLI, it's still busted.
Yeah, the old VC, was it VC 2.0?
A lot of people in Virtual Center 2.0 basically did a lot of data store provisioning via the CLI, right?
And it would not take in consideration the proper alignment of the VMFS file system on top of these blocks. And so what you want to have is you want to have an alignment here, and you can see I'm kind of animating this, right? You want to have an alignment so that when your reads are being when your I/O from your virtual machine is being asked to read a set of blocks, you are only reading that set of blocks, okay? And this is just a simple equation of efficiency, right? By show of hands, anybody here be interested in virtualizing their systems if I said there was a 30% overhead for doing so? Probably not. You might have a 20 or 30% overhead for having a misalignment at this layer, okay? Building on top of this, you have virtual disks. And this is primarily where we see more issues than in terms of misalignment than VMFS data stores. This is the virtual disk file, and that virtual disk file has a partition inside it as well. Those file system blocks, or which are referred to as clusters in this screen, are most often 4K in size, though they can be larger. Right? The default file system allocation unit size in NTFS or ext3 for a drive greater than 2 gigabytes is going to be 4K, so this is probably what you're using. And again, you want to make sure that when your read requests come in that they start and stop on a boundary that aligns with your storage controller. So this is mapping a virtual disk back to a physical construct in the storage controller.
This also, if not done, incurs a much larger parity write penalty, right? Because what occurs is that the writes span the underlying RAID stripes or chunks, right? So you end up needing to do more RAID overhead. And again, all array architectures vary, but there's some degree of extra workload that's incurred.
Yeah, a lot of non-storage folks don't realize that when you, as a storage controller, execute a write request, there's actually read processes in that, which is go read and find on the disk where you're going to write this data.
Yeah.
Right. So what you need to know about alignment as it comes to building your virtual machine images or doing a P2V process, which is first and foremost, this is going to impact what we'll classify as legacy operating systems. Windows NT, Windows 2000, Windows 2003, XP in the desktop side, right? These are systems that if you have these images in your inventory and these are templates, please go back and correct your templates, and we'll cover that in 1 second. If you're deploying current generation operating systems, and again, I'll stay within the Windows family, Windows 2008, Vista, Win 7, we've worked with Microsoft to get Microsoft to go ahead and take care of this for us. And they've now implemented what I'd like to have you consider a cloud standard, a starting offset of 1 megabyte in all their operating systems, and this works the best across every storage platform.
Right. So Linux, by the way, even the modern Linux distributions and the latest Linux kernels also require you to do this offset manually. The one thing that's I just want to point out is you'll go out on the blogosphere and you'll see articles that, make recommendations of all sorts. 64K is the magic value. 32K is the magic value. 4K is the magic value. The answer is that every array has a magic value where if it's less than that value, it's bad. But if it's more than that value, while still being a multiple of 4K, it's good, right? So what we've kind of have said is, based on everything we see going on and everybody's thing out there, if you do it on 1 meg, you're always safe.
Yeah.
And it's important because we know that if you use the magic value that's lower for your particular array, and then later on you change array types, realigning to new bigger values is hard. So how do you realign to new values? How do you realign?
Right. Yeah, so the process of realignment today requires you to take the virtual machine down and leverage a number of tools. There are some that are free through the community, right? There are some that are free from storage vendors. And then there are some nice, very elegant, GUI-driven, with scheduling and reporting capability tools, let's say, like vOptimizer from Vision Core, that will allow you to basically rewrite your entire virtual disk. So your virtual machine will be down in some ratio relative to the size and capacity of the data stored within that virtual machine.
So in other words, painful. So the best solution is do it right up front.
Yeah, there's nothing worse than saying, I don't want to do the effort, I got 100 virtual machines, I don't want to align, and then 3 years later going, I've got 3,000 virtual machines and now I need to align them.
The one other thing that I'd say is sometimes if you have a VMFS volume that's misaligned, and one thing that's important to note is we're talking about VMFS, the question of guest OS alignment applies to NFS-based data stores.
Absolutely.
Right? So you need to think about this, regardless, again, block or NAS models. If you have a VMFS volume that's misaligned, in other words, you created it with the CLI as opposed to within vCenter or earlier using Virtual Center 2.0, 2.5, if you do it in the GUI, it automatically does the alignment offset, right? But if you did in the CLI to fix it, your choice is basically create a new data store and storage vMotion everything in, right?
Real quick, if you may, one of the things that we don't have on this slide, if you have a large number of virtual machines, it can be hard or very challenging to go in and understand which of your virtual machines are misaligned. I think the quick and dirty way to understand if you have misaligned virtual machines is to say, do I have any version of Windows prior to 2008, and did you manually create the starting partitions, the starting offsets of the partitions in those virtual machines? And if you go, that means you've got a problem. Right?
Right.
The second thing is you could leverage something like vOptimizer Pro, which will do a scan of your inventory for you on any one storage platform and provide you back with a report allowing you to target which machines to address. Our tool, which is our RMBR Align, has a function of scan, which again will scan data stores for you as well. So you can do it without having to log into the guest to understand the values. If your VMFS file systems are misaligned, you're probably going to need to rely on your storage vendor support team to tell you if it is or isn't.
And if you do really like being a propeller head, you can actually go in and see like how many stripe crossings you've got. If too many stripe crossings, bad. Let's take the questions at the end. Absolutely. If possible, all right? So, go ahead. Keep on trucking. iSCSI specific considerations. So, first things first. How many of you are using iSCSI?
Very good.
Great, that's fantastic. So iSCSI, typically in my experience, is the block choice very often for customers who have no existing fiber channel infrastructure, right? So can you make iSCSI scale and perform? And the answer is yes. iSCSI is an area where, out of all of the protocols, I think that there's the most variance between different vendors. And it's because the iSCSI implementations vary pretty significantly, right? So this is a bit of Chad scrawl. I don't know whether we've got a pointer here, but let me see if this works. All right. So basically, the way iSCSI works is it's an initiator target end-to-end session. This is the ESX host. Oh, too bad. On the right, the ESX host logs in over an Ethernet network to the target, right? Like literally, if you put a Wireshark, and you listen in on the wire, you can actually see, the iSCSI commands that make a login or a session disconnect. And inside that session, inside the protocol standard, not within vSphere, you can also have multiple connections. In other words, multiple TCP connections within the same connection. Within vSphere 4.0 and 4.1, you can't do that, but what you can have is you can have multiple of those purple pipes. In other words, you can have multiple sessions to a single target. Now, the reason that this is important is that everyone's array does the question of how do they present a device, a LUN, out in a different way. Some of us have a model where a LUN is presented out via multiple targets, right? So a target could have multiple LUNs behind it as well, right? Some of us have got a model where there's a one-to-one model where every LUN is the target, and there's a session directly to every single one of the LUNs. Again, it's not so much that there's a right way or a wrong way. There's just no specific way to do it. So there's a whole slew of stuff about setting up iSCSI properly in vSphere 4.0 and 4.1 that basically involves creating multiple VMK NICs, putting them into active or standby for an individual iSCSI session, and then using the CLI to explicitly bind the iSCSI software initiator to one VMK NIC versus another. Rather than me explaining it, this is an area that we cut. The session that covers this in awesome detail is TA8133-Best. I don't think it's being repeated anymore, but if you're an iSCSI customer and you want to know the do's and don'ts for iSCSI, I'd highly recommend that you get this content. If you have a chance to meet him, it's presented by Andy Banta, who's like Mr. iSCSI at VMware. A tall, giant bear of a man. He makes me feel like I'm even shorter than I am.
I like your picture with him yesterday, though.
With me on the chair?
On the chair?
Yeah.
That's good.
And his hair goes down to like here. He's awesome. But in any case, he explicitly goes through the step-by-step, how do you do that, do's and don'ts around basic iSCSI config. So I'd highly recommend that. Now, I'm going to expose some warts. So I think it's an important thing for us to be explicit about do's and don'ts. So there was, the engineers agree this was a bug. The product marketing people would say, oh, it's a workaround, feature, right? Come on, this is VMworld. You're nerds, I'm a nerd, it's a bug. Basically, when an iSCSI session connects to a target, the first thing that it uses is its IQN, the iSCSI qualified name, a long thing that says IQN dot, blah, 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 blah. It has like a domain name associated with it, something that looks like a domain name. But then the session ID, the iSCSI SID as it's called, right, is the combination of the IQN plus the IP address, the source IP address. In versions of Flare, do we have any Clarion customers out here? Or Solera customers using block access? In versions prior to Flare 30, what occurred is that it stored the session just using the IQN. And what that meant is that if you had an ESX host with multiple iSCSI interfaces, and of course multiple iSCSI interfaces just came in with vSphere 4.0, right? That you could have multiple interfaces for a single IQN. And they simultaneously logged in if, just for fun, Vaughn is the EMC storage array, and I'm the ESX host, right? I'd log into the array says, hey, I got it, and then I'd log in again via this other IP address. Okay, hey, he goes, hey, wait a second, that's the same one that just tried to log in, I'll disconnect it. And then I go, whoa, wait a second, this one just got disconnected, I'm going to try and log in again. And what you'd end up seeing is you'd see all these sessions going up and down, up and down, up and down, and up and down, right? And what that meant is that you'd get lower iSCSI throughput than you expected because there's a lot of this session chatter that's going back and forth. So if you're using an array pre-Flare 30, there's a right way that's a workaround, which is basically you put the different iSCSI interfaces onto different subnets, and you basically only allow them to log into the ports that are the same subnet, right? This is a workaround. Right, not a solution, right? If you do it, there's no degradation in performance. You'll drive both of the Ethernet, ports at their full speed. But really, it added a little bit of complexity. The good news is Flare 30 is GA, and Flare 30 fixed the bug. You can put them all on, single subnet and go at it, and it just works. This bug's been resolved.
Well, while we don't have this on the slide, I do want to share that there's some warts on the NetApp side with this configuration as well, which is, oh wait, we didn't have any. Never mind.
Yeah. So there's another caveat I want to put out there, right? So this applies to EMC Unified and EMC Clarion configs, right? Block-only configs.
Actually, I could take this. So we do want to talk about a wart, right? We brought it up yesterday.
Yeah.
So we share chipsets. We share a lot of hardware components inside of the storage controllers. And by show of hands, how many of you are using one of our storage products with 10 gigabit Ethernet ports? Okay, thank you.
Thank you, yeah.
You may want to follow up and make sure you're using some of our latest revisions of our code. There's been some firmware updates for the 10 gigabit ports.
Yeah.
Help keep you from maybe not going as fast as you'd like to go.
Right, and I'm going to give you the detailed specifics on the EMC example in here right now, right? So basically what happens is that the specific bug has to do with this TCP selective ACK and TCP windowing behavior. And we won't say, which part inside the arrays is the guilty party here, right? Because it doesn't matter. That's not your problem. That's our problem. But basically, what happens is that if you're trying to drive 10 gigabit Ethernet iSCSI performance, and you see depressingly low throughput, you got to make sure that you're using either Flare 29, and there's a patch 3 for it. There's a similar one for Flare 30 that basically fixes this particular bug. And I think in your case, it's 7.2.
Yeah, if you're a 7.2 customer, it's good. You need to move to 7.2.6. And if you're a 7.3 customer, you go to 7.3.2.
Yeah. Okay. By the way, there's an implicit thing in there, which is it's important to try and stay current, right? Try and stay current on the array firmware. We know that it's not something that you want to be updating all the time, right? So we try to not do it unless there's something that's pretty important. But also always make sure that you're looking at the VMware HCL, right? Because sometimes we actually issue firmware before it finishes its HCL qual with VMware, right? So that's the sequence of taking a look at things. Okay. Now the question that we often get is how fast is fast, as people want to do more and more 10 gigabit Ethernet. Well, the answer from a marketing standpoint is damn fast, right? So the first example is on the iSCSI side. Here it was going to CX4960, single 10 gig interface, single VM. We're driving it at 2.5 gigabits per second. And then we did another one at VMware last year where we created a big scale-out NFS data store, lots and lots of interfaces, 6 interfaces, and we're driving at 32 gigabits per second, right? So you can go really fast. Now, the question that always occurs, though, is people go, can I drive it at line rate? Can I go really fast? I want to compare and go should I go 8 gig or 10 gig? Well, 10 gig is faster. And, sometimes the sales teams kind of oversell this stuff a little bit.
Yeah, and I'd like to make a comment on that. If you look at any I/O benchmark that achieves line rate, it will have this pattern. It's a very common pattern. 100% reads.
Massive I/O size.
Very massive block size, right?
Yeah.
A block size that I will challenge you to find an application you run at like 256 kilobytes or 128 kilobytes. Not that they don't exist, it's just not the norm, right? And it'll be all reads. That way it can all get cached or come off of it. Well, in the past cached, today off of SSD. And that way you can fill the pipe. In your 4K and 32K transactional work today, you're going to be hard-pressed to fill it.
Right. So I wanted to do something that isn't an expression of absolute array limits, but I wanted to set expectations for customers that are doing this. I'll say it for us. You can make any color commentary you'd like, which is, if you take a look back at this slide, I skipped over it. We've got these modular I/O designs, so you can have you can hot add I/O ports, and you can have very high port density, right? A single 10 gig I/O module, whether it's the native FCOE module that does multiple protocols, or whether it's just the straight up 10 gig E module, what you should expect is about 2.5 gigabits per second as the upper end limit max for a single interface, about 5 gigabits per second as what we call the SLIC, the module maximum, and for an EMC high-end Clarion or unified array, for the total array for iSCSI, think of it as a maximum of about 16 gigabits per second. We can drive a little bit more on the NAS side, but think of those as upper end limits. I'd have to say, in my view, those are pretty high, right? It's a rare customer who has a requirement that's above and beyond that. We can solve those problems, but for what it's worth. Okay, multipathing. So
the halfway point.
Multipathing. It's a very important thing to understand that multipathing for block devices is very different than multipathing for NAS devices, right? So a lot of people look at it and they go, well, if it's Ethernet connected, what is my primary mechanism for path failover? And for people who are more used to the networking world, they immediately think that it's the underlying networking link aggregation type approaches. The answer is that all block multipathing things are end-to-end multipathing behaviors, right?
Well, real quick, I'm sorry.
Go ahead.
In the VI3 realm, right, when we would have customers stand up iSCSI, we absolutely had to leverage intelligence in the network.
Right, because there was no other choice.
There was no other choice. In the vSphere world, you were going to handle your block access in a uniform fashion. iSCSI, FCOE, or FC, you are going to rely on now basically giving links with no intelligence and move the intelligence into your multipathing agent.
Right. So, now this is a bit of an interesting one. So often we get into big, furious, again, debates, active-active models, active-passive models. So do we have any Symmetrix customers in the audience? So Symmetrix, DS8000s, USPV from HDS, those things often, they get grouped into a category of thing that in the VMware list says active-active. What that means is that a LUN is simultaneously presented via all possible ports in an array, right? And there's another category that VMware calls active-passive, which sometimes people immediately jump to the erroneous conclusion that says, hey, wait, is one head idle the whole time? What active-passive means to VMware is that a LUN is owned by one brain or the other brain, right? I think we both call them storage processors or storage controllers, right? Every vendor calls them something slightly different because we want to make it confusing. Of course.
Why
right?
standardize?
Why standardize in the name? Okay. So the thing that's important is that in this active-passive array designs, which are usually characterized by like 2 brains, there's also these what's called the virtual port design that's used by Equalogic and by Left Hand. In the active-passive category, there's this technology which is a SCSI standard called ALUA, Asymmetrical Logical Unit Access. And what that means, if we kind of decode this, by the way, support was introduced in vSphere 4.0. And by the time the vSphere 4.0 came out, I can't think of a mid-range or a active-passive array. You know, again, the names are all bad because they don't, quite nail how the arrays work. But they all support ALUA. ALUA support is now incredibly broad, right?
Yeah, it's a standard.
Yeah. So what it means is that all of the brains of the arrays that are these active-passive models in VMware nomenclature means that while a LUN may be owned primarily by one brain, they use the internal interconnect that's used to keep cache state and stuff like that current to be able to present out via the ports on the other brain, right? Now, those paths have a slightly higher cost in terms of latency, in terms of load on the brains of the arrays, and how much that is varies depending on how the individual array vendor has implemented it. But basically, those report themselves up as active and active non-optimized, right? So VMware won't, and bless you, VMware won't send any I.O. down the active non-optimized paths until the path goes dead. But ALUA is a good thing because it makes multipathing fundamentally easier since all paths are shown as active. So this is a good one to say, well, how could you get there if you're not currently using, and the problem is that what happens if you're migrating from 3.5, which didn't support ALUA, to vSphere 4, which does, and later, which does support ALUA.
So we've had a number of customers that have wanted to complete what we'd call or consider an in-place migration from VI3 to vSphere. And what that means is I've got my storage connectivity, I've got my host. I'd like to just, on a host-by-host basis, move them into maintenance mode, migrate the virtual machines off, upgrade that host to vSphere, bring the virtual machines back, right? Rinse and repeat. Let's just go through all the hosts in our cluster. And so you can do this, but the issue is because VI3 doesn't support ALUA, you can't enable ALUA while you're completing this process. If you want to enable ALUA after the process, then you're going to go through and actually reboot all your hosts again because the ALUA session is actually established as a handshake when the ESXi host comes up and logs its initiators into the storage controller. So we've worked together to come up with a means, and again, this should work industry-wide with all the vendors. Again, the terminology is a little bit different, but a way for you to be able to accomplish this. So what we have in this image here is we have a 4-node 4-node VI3 cluster, and you can see it's surrounded by a box, and the blue line comes down into a blue box that's called a LUN mask. And then from that LUN mask, you see the LUN to the left. Sorry, I'm on stage. What a LUN mask is a LUN mask is a method which grants access from initiators, which are iSCSI, Fiber Channel, FCOE cards inside of each host, to that LUN. This is how you delineate which hosts are talking to your LUN, right? It's quasi means of access, granting access / security to the LUN. Now, this LUN mask, you can have one for each of your hosts. You can have one for each of your initiators. Some customers just make one per cluster. Mm-hmm. That's however you prefer to manage. There's pluses and minuses to those designs based around simplicity and also security, so there's a little bit of trade-off. But the long story short is, within the storage controllers, when you want to do this in-place migration, if you create a second LUN mask, and this is the LUN mask that would have ALUA enabled on it, as you migrate out one of your hosts, when you put one of your hosts into maintenance mode and you begin the vSphere upgrade on that host, if you migrate out its initiator addresses out of your LUN mask for VI3 and move it into the new vSphere ALUA-enabled LUN mask, right? When that host comes up, he'll still be connected to the same LUN as all the VI3 hosts. You'll still be able to accomplish any tasks between the hosts that you could, in the past. But now the vSphere host will automatically have ALUA enabled and will have greater options in terms of path selection and path intelligence to the storage controller. Does this make sense?
Okay. Cool. So the question is, should or shouldn't you use ALUA? The answer as a general statement is yes.
Absolutely.
So Alua is supported if you're fiber channel connected on all EMC Clarion, EMC Solera arrays. Symmetrics is active-active, so you wouldn't use Alua. It's supported on all FAS and V-Series and also on the IBM N-Series arrays.
Yep.
On FCOE, native FCOE support, it's again supported uniformly. iSCSI implementation on NetApp is slightly different, and you don't really need Alua for that particular case. If you're using in EMC iSCSI on again either our unified or Clarion arrays, you can use Alua. And in fact, it's not you can use it; it is our recommended best practice setting. So, understanding the whole idea of MPIO relative to link aggregation is MPIO, as we've said, is an end-to-end thing, right? Link aggregation techniques apply basically on one Ethernet hop. So the way that this is done within vSphere 4 is via something called the pluggable storage architecture, right? vSphere 4 changed this actually pretty significantly in storage land. This is really exciting. I mean, but to customers it's not that exciting, so I'm not going to spend a ton of time on it. What it changed was previously, if you were a storage vendor and you introduced either a new array or you realized you wanted to change the path behavior of vSphere, the only way for you to do it was to basically wait for the next major U release, kind of train. So you were linked to how VMware was changing their VM kernel, right? So what they realized is that a better way to do it is to make it a pluggable architecture. There's three parts to it. There's basically the SATP, which is the storage array type plugin. When your array identifies itself and says, hey, I'm an EMC array, or hey, I'm a NetApp array, or hey, I'm a whatever type of array, the SATP gets selected for that particular type. The SATP governs a path discovery, killing paths. When do you have a path that's dead? How long do you wait until you make it dead? And it can also govern some queuing behaviors, right? Because arrays had certain different behaviors depending on queue full conditions and stuff like that. The PSP is the path selection policy plugin. And basically what it does is it selects which path out of all the ones that I know do I send an I.O., and together those make NMP, native multipathing. There's also something called the MPP, which is the multipathing plugin. The multipathing plugin can change the entire set of stuff that the multipathing behavior of the VM kernel can do. So, what's out of the box in vSphere 4.1? If you issue this command via the VMA, you'll see the SATPs that are there. And the way that these show up is that when you add, if you went under, configuration and under the, storage properties, you'd basically see for any individual device, underneath that individual device, you'd see one of those things on the left. These things get picked automatically, right? And govern those sorts of behaviors. Now, what about PSPs? The PSP is automatically selected out of the box based on the SATP. If the SATP is associated with an active-active array design, it'll default to fixed path. Fixed path means, hey, once again, this time you can be the ESX host. I'll be the array.
This time I'm talking to Chad and I'm on a fixed path, which means I'm going down path 1 for my I.O. My path 2 is my standby path.
Yep.
And should my primary path fail, I will start sending I.O. down my standby path. When link state is returned, I'm going to return I.O. back on my primary path.
Right. If it's an MRU-based PSP, what it means is that, hey,
Again, I'm sending data down a primary path or link 1. If I have a failure on link 1, I will start sending I.O. down link 2. But this time when link 1 is returned, the state is returned on link 1, I'm still going to send my data down link 2. I'm not going back to the previously failed state.
And the reason that this is there is that prior to Alua type designs, there was the possibility in some circumstances to have like path thrashing, right? Where the path would go over to 1, the LUN has moved over, and then it goes back to over here and goes, hey, wait a second, I can't read the LUN. The array would flop it back over to the other storage brain. By the time that it flopped over, the ESX host has already said, hey, wait a second, it's not there, and going back and forth.
Get a bad GBIC, a bad ASIC, a bad piece of fiber. And
exactly. You'd go back and forth and back and forth. So, and in vSphere 4, they introduced the idea of round robin. The way round robin works is like this.
So round robin works, which is I've got multiple paths. I'm going to send some data down this path, some data down this path, some data down this path, some data down the next path.
Right. So the sum data is a value of n.
Yes.
And then people get all excited about what should the value of n be, right? There's a way via the CLI to change this generally. Now, what I'm going to say here very briefly is both of our plug-in type models automate this process, right? So, I'd rather than explaining you how to do it via the CLI, I'd rather that you use the plugins, which make it simple and easy.
This is geek secret. This is not recommended best practice.
Right. But you can change the default policy. So, for example, you can change it to natively select round robin anytime the device gets selected, as opposed to picking fixed or MRU. Now, this I/O operation limit thing, what's the value of n? It's been tested by both EMC and by NetApp. I can't speak for the other folks, but I'm sure they have. It's supported. If you change it, it's not like you fall out of support love. But you'll see graphs like this that say, holy smokes, look at how much better it is if you turn that value to 1 as opposed to the default, which is 1,000. So 1,000 go this way, 1,000. That doesn't seem, it seems like it should just go 1, 1, 1, 1, 1. Well, the reality of it is that you can create artificial tests, and typically this is what people do. They're like, hey, I want to find out what the best value of n is. I'll create a data store. I'll put a VM in it. I'll run a iometer workload against it, which has one very fixed, thing. And look, hey, it's way better or way worse. Of course, that's not how a real-world environment looks like. A real-world environment has boatloads of data stores with boatloads of VMs in it, doing all sorts of weird, crazy I/O sizes, right?
Yeah, so 2 comments. So first and foremost, if you are looking at any form of benchmarking and testing for I/O performance within a VMware environment, not completing that on a multi-node cluster is a completely invalid configuration.
Right.
And it happens time and time again. Right? We are building shared infrastructures. If you are not sharing, then you are not benchmarking. 1. 2, we did test this in-house, and I will speak from the NetApp side. We tested it on a 16-node cluster and went through iterations of taking the value of 1,000 higher and taking it lower. Right? And obviously, we had increments that we had selected arbitrarily. At the greatest point where we can measure a delta between the default and some improvement, it was 8.9% when we purposely saturated all the links. And as we stated earlier, your likelihood of saturating a link is going to be very uncommon. So while you could change these values, I'm a huge proponent of set it and forget it. Keep things simple.
Yeah.
It will keep it available in the long run. Just leave the default.
Absolutely. Okay. So PowerPath VE. So for people, is anyone here a PowerPath VE customer? So one thing that was interesting in PowerPath VE is an MPP. So it changes the entire model of how multipathing works in vSphere 4. It's a VM kernel loadable module. In vSphere 4, you needed to be using Enterprise Plus. In vSphere 4.1, you can be using Enterprise or Enterprise Plus. So there's a funny story behind that. Talk to me over a cocktail. I'll buy. All right. So it changes the queuing behavior to an adaptive model. So it looks at the queue depth on the host and varies path selection based on that. It also looks at the ports on the arrays and figures out the queuing models there. Again, it's up to customers to choose. We support NMP. It works. NMP works fine. PowerPath VE does tend to simplify the path configuration on the whole. But there's other ways to solve that problem too, which we'll show you.
Absolutely.
There's other third-party MPPs starting to arrive in the market. Do we have any Dell EqualLogic customers here? So the Dell EqualLogic MPP basically leverages the behavior of the virtual SCSI session kind of characteristics of the EqualLogic Pure Storage Array, right? So it will basically redirect paths down across controllers in a more fluid way, right? So if you're an EqualLogic customer, I'm sure that they're showing you this at the Dell EqualLogic booth, right? So check it out. What are our specific MPIO recommendations? Well, if you're using Flare 28.5 or later, use a Lua, right? Use a Lua and configure for failover mode 4, that's how you do it, and then configure vSphere for NMP round robin. If you're an older generation CX3 or AX customer, use active passive, which is we call failover mode 1, and configure the NMP for MRU, which will be the default. If it's a SIM, and any generation they're active-active models, you should use NMP round robin. And if you're using PowerPath VE, which supports EMC and non-EMC arrays, all this stuff kind of is figured out. So what I thought of here is I'd do a quick demonstration of how this thing works. So it's supported with vSphere 4.1 today, and in fact, as of this week, it's now also supported on ESXi, so both ESX and ESXi. The way that this thing works as a VM kernel loadable module is we wanted to make it really simple to add it. Previously, we were using the VI host update CLI process. People didn't really like that. So what people wanted to do is they wanted to be able to install it and update it via VUM, right? Just like they do any ESX patch. So if you go over to VMware Update Manager, you can do add what's called an extension baseline. An extension baseline is a third-party extension to the VM kernel. So this is also how you can do updates for the Nexus 1000V, right? So both Cisco and EMC kind of worked along and go, how do you use VUM for these third-party VM kernel modules? And once you go through that process, it's basically like applying any VM kernel patch that requires an ESX host reboot. It's going to stage the patches. It's going to go through and put the host in their maintenance mode cycle. And one by one, boom, 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 they come up and PowerPath VE is installed. It's a very fast, very simple process. One thing that we're working pretty hard as well is to improve the licensing model, to make it more integrated with VMware's new licensing model. So lots of work going on there as well. So here you can see that it's reconfiguring the cluster. Okay, fantastic. We're not going to go through and watch the host reboot. But the point is, once it's done, PowerPath VE is installed, and PowerPath VE is embedded directly into the whole vCenter UI as well. So when you go and you take a look for a path state, you can go and you can see, okay, fantastic. Is this device owned via PowerPath VE? Is this path device owned by NMP? You can actually have a mixed environment as well. At that point, all path behavior is changed, simplified in some significant ways. So I'm not going to go through this any longer, just in the spirit of time.
You missed one. So taking the same considerations and applying what are the best practices for MPIO settings to the NetApp customers, or also the customers who maybe are using IBM N series. As Chad had stated earlier in the session, storage controllers at the end of the day provide you storage, but the architectures are fundamentally different. So while we still have to address MPIO settings, the means of how we do this is through a different manner. On the NetApp side, while you can manually configure your settings, again, our best practice is to leverage our free storage plugin, which is called the Virtual Storage Console 2.0. This plugin provides you a number of feature sets, including the management of your path and path selection policies. Okay, this is a free plugin set. And what this is going to allow you to do for SAN and NAS, and when I use the word SAN, I actually mean fiber channel or Ethernet, and iSCSI. Okay, that, again, may be a difference of terms depending on who you're speaking to. But this will allow you to set up your path selection policies, your multipathing policies if it's a LUN. If it's with NFS, it will go ahead and use some logic to manually establish which paths each data source should be connected on. There's some logic that it pulls from your network design. Again, those network designs are covered in our best practices guide. But it will allow you to, in the best manner possible with NFS, distribute the load for those architectures. It will also then take care of securing the access. So remember those I groups or those LUN masks we shared with you earlier? It will actually dynamically build those out for your hosts. And if it's NFS, it will go ahead and actually secure the NFS exports for your host. So I realize I'm kind of conflating block and NAS here, but that's kind of how we drive our functionality within the unified architecture. Best practice is, when possible, run the latest certified version of Data on Tap in your environment. So that would today be Data on Tap 7.3.3. Okay. So we've put together a little demo here. Do I have to kick this again? And I'm going to show you two things. First is the means to get to setting up storage multipathing actually comes about in a different way. What we have here in Virtual Center is actually a storage administrator logged into Virtual Center and assigning storage resources, I/O interfaces, and either groups of physical disks or logical disks, which we call flexible volumes. This is, in essence, the storage admin provisioning storage resource pools for consumption by the VI administrative team. Now, some customers, right, their storage controller only serves a virtual infrastructure. Other customers, it's a subsegment of the storage controller. But at the end of the day, storage admin is getting out of the task of provisioning storage, and now we allow within vCenter a VI admin to be able to draw from those resource pools on demand, SAN or NAS. Again, the options will be available to them based on what's licensed. And when they provision storage, either to a host, a cluster, or the entire data center, you'll see that we walked through a wizard here, and the video went a little faster than I spoke, but you'd walk through a wizard, and there was no option around path selection. There was no option around multipathing. We're not trying to make you storage experts. We're trying to let you manage your business and go as fast as you can to meet your demand. We allowed you to pick what type of data store did you want. You give it a name. Do you want it thin provision, deduped? Where do you want to connect it to? We'll take care of all the rest of these options for you, right? This is simplicity driving down, right, your time and your decisions and eliminating human error so that you can have consistency and greater resiliency. Okay. What I didn't do on this video, and there's plenty online if you want to look at it, is actually show you and validate how the paths were selected. But again, going about things in a little bit different manner, but ensuring that your best practices and the path selections are taken care of.
Just a quick show of hands, right? How many of you are using either VSC, provisioning, automation, all that sort of stuff, or VSI, which is the EMC vCenter plugin that does provisioning in that similar model? Show of hands.
That's not enough.
That's not enough, right? It needs
enough hands.
So one thing that was depressing is I asked the question of like, what frustrates you most about storage in VMware land on that survey, and I was expecting like performance, or I hate my storage team, or like stuff like that, and I was depressed to see how much of it was, I know how much coolness there is that I don't use. The plugins are there to make it simple and easy in the natural context of the VMware team to automate those things.
I have a question. By a show of hands, how many in the room would find it useful if we got together and wrote a post speaking to storage management teams about how to enable the plugin for the VI admins and the business reasons for doing so? Would that help some of you? We got a task.
That's a good idea.
We got a task.
Right. Okay. There's some weird exceptions to MPIO, right? And multipathing in general. And there's, in fact, some weird things around just Microsoft clustering in general and Windows services for clusters. Technically, it's just a weird nit. They're only supported today by VMware on top of fiber. Now, this has been officially tested by EMC eLab. I'm sure it's been tested by our cohorts at NetApp. It works fine on the other protocols, right?
Absolutely
It's just
great.
Now, again, we're not advocating by saying that you break the support model, because that's not good, right? How many of you have either MSCS or Windows Services for clusters inside your VMware environment? Great. Right. The lower the better, right? Like as much as possible.
There are alternatives.
Right. The other thing that's weird is that you're not allowed to use round robin.
MRU.
Exactly. So, you basically have to be very, very specific configurations of behaviors. And this does matter. I've actually seen support cases where this gets brought up and it's a not supported configuration, even though that's probably not the root cause.
So what we're saying is if you need support for this in your environment, and again, you can tell by the show of hands, this is not necessarily the norm, but if you need support for this as you migrate an application in from the physical realm, and it has to run over iSCSI or FCOE, please continue to drive through your VMware support team.
Yeah.
Some customers have been able to establish one-off support. The more requests that the field is driving into VMware, the more likely you are to have this all complete a QA cycle.
The one thing that's interesting is if you're using iSCSI, the iSCSI to guest, which I'm not a big fan of breaking the encapsulation model in general, right? But the iSCSI to guest model does allow you to have multipathing and MPIO behaviors and use that. So,
and just to clarify what Chad is stating is, if I put an iSCSI initiator inside one of my guests and allow that traffic, which will look like network traffic to the ESX hosts, handle the traffic from a storage object back to the virtual machine.
Yeah.
You can accomplish it in that manner, and from that standpoint, VMware steps out of the loop and says, I don't know that you're doing storage I/O traffic, so what you're doing with it is then best put back on the storage vendors. And we support that, but again, it then has a downstream effect in breaking other applications and integration points.
Yeah,
like makes SRM much more complex as an example. We'd rather you just drive into a support model.
Okay. NFS considerations. So there's again, the key thing around this, I think, is this is an area where a lot of work's been done, both by NetApp and by EMC. We're both leaders in this space. I don't see too much of the other NFS servers attached to VMware. We're just referring back to the same docs you saw earlier. The best practices docs here are solid, important to read. The plugins from both of us automate all the setup, all the load balancing, all the path distribution and set up the NFS exports, all of those sorts of things. So use them. The other thing that we wanted to pause here for a moment and just say very briefly is use 10 gigabit Ethernet. 10 gigabit Ethernet is no longer weird, right? It's mainstream, and the reason that this is important is that right now vSphere uses NFS v3, which means that a data store is going to end at an IP address, and that all the traffic to that IP address is going to go across a single Ethernet link, which means that sometimes you're going to be constrained in terms of the bandwidth, not IOPS, right, but bandwidth. How many megabytes per second can you set to that single link? If you are using gigabit Ethernet, your choice is basically use multiple data stores. Increase the data store maximums if need be.
So just real quick, I don't know if you recall, but Chad had a slide up earlier, and it showed a bunch of links, and we were talking about iSCSI, right? And I wanted to make a point that said, with vSphere, and we design iSCSI, we just want dumb links. There's no intelligence from the Ethernet in terms of failover or link aggregation. We have an intelligent client, which is the MPIO client, which is going to allow us to get link aggregated throughput between our links, also give us our link path failover. Okay. With NFS, we are still leveraging the constructs within the Ethernet to provide us our resiliency with NFS, and this is because of the client. NFS version 3 is very robust and a very reliable client, but until we move forward and move on to parallel NFS, which is in the works, when that happens, you'll basically have the equivalents, in layman's terms, the equivalents of MPIO settings that you have within the block side for the NFS.
We are working furiously on PNFS, both on your side, my side, and on the VMware side. There's some important best practice settings. To net these out, these are very important just to make sure that timeouts at the ESX host and timeouts inside the guest are designed for the timeouts of the underlying NFS servers. Again, if you use the plugins, these are all set up automatically.
Yeah, there's no need to take these photos, guys. Use the plugins.
Use the plugins, seriously.
Much better way. Not only that, the plugins will audit as you stand up new ESX servers, so you can always ensure compliance between your servers, right? Your environment's going to grow.
They'll even go back and fix wrong ones.
Yes, so non-disruptively correct things, so use plugins.
All righty.
So real brief, we wanted to introduce this topic. A lot of customers will sit there when they start talking about NFS-based connectivity and wonder about resiliency and throughput with their I/O. And we typically have to ask our VI admins, do you know what type of switching technologies you have in your environment? And they usually look at us and go, well, Cisco, what else do I need to know, right? So we've classified switching technology into two categories. The first one we call traditional Ethernet switches. And what this means, and I'm sorry, I don't have any vendors and model numbers to share with this. I will on the next slide. What this means is I have two switches that act independently. While they may be linked to send traffic together, they are just two unintelligent switches that act independently. And as such, I have to leverage more complex network designs if I'm on a single gigabit Ethernet storage infrastructure. Okay? And if I want to ensure availability and robust throughput to my ESX host, this is going to get complex and require multiple IP addresses. If I'm using what we consider modern switching technology, which I'm sure most of you have, these switching technologies have what we call, and it's a generic term, multi-switch link aggregation. And this can be found within the Nexus line from Cisco with the virtual port channels, the Catalyst 3750 cross-stack Ether channel systems, as well as some of the older Catalyst 6500 series with the VSS module. Okay? What this allows you to do is to link two physical switches together that fundamentally operate like one logical switch. And it gives me greater Ether channel resiliency across the switches. That's why I'm in IT, I have bad hand-eye coordination. And it's much, much simpler in your Ethernet design. I think we're out of time here. So we've made this kind of high-level logic chart for you to follow so that you can understand how many IP storage networks I need if I'm going to do an Ethernet path or an NFS-based configuration, and it really relies on my Ethernet switches, and that will have a trickle-down effect into how many networks do I require.
Applies to both Solera and FAS equally. Follow the flow chart; it's pretty straightforward.
So real quick, and we've got the door open, but we've got like 2 slides. We'll hit this uber fast.
Yeah.
The concept we hear repeatedly for iSCSI and NFS customers, should I use jumbo frames? And while it is a badge of nerd honor if you've enabled jumbo frames, inevitably your staff will grow and change in size. You'll get in new gear. The new ports will get stood up. New servers will come online. At some point in time, someone's going to forget to set that jumbo frame on some device somewhere, and now you'll have a troubleshooting problem. Jumbo frames in the past were really a means to try to increase throughput and performance. And when you would say, well, what's my bottleneck? It would be like, well, I'm trying to reduce CPU load.
It's weird. People would jump to jumbo frames as the first fix. And
Yes.
generally, it's very rarely the root cause for storage networks, particularly with smaller I/O sizes that tend to be more prevalent unless you're talking about a data warehouse or something like that.
Yep. So our best practice for general purpose, and this means 90% of your virtual systems, there's absolutely no need for jumbo frames. Set it and forget it. Keep it simple. Just plug and play with Ethernet. There's a tremendous amount of horsepower in all of our systems today. You don't have to worry about processor consumption within any of the devices, network, storage, host.
And just so we don't debate it, guys, we're not saying that you can't squeeze out a little more if you turn on jumbo frames.
You can.
That's not the point, right? The point is keep it simple.
Remember Chad's slide we opened up? We showed this massive cluster, all this I/O going down, and what did we say? When you have a storage problem, you're not affecting one host anymore. You're going to affect all of them. And sometimes chasing down where that problem is can become more difficult. The easier you make it, the better it's going to be for you in the long run.
This one here is just TCP flow control is an important thing for any Ethernet network that's very busy and very chatty and a lot of traffic. And that's very common in storage IP land, both for NAS and for iSCSI. There's some specific recommendations about how to set up TCP flow control, which you guys can see here. I'm going to just skip it in the spirit of time. This one's an important one for customers that are using iSCSI and NFS together. Long and short of it is that these are all VMK NICs. You assign the iSCSI software initiator to specific VMK NICs, but there's nothing stopping the NFS client from using all of the VMK NICs.
And what we should point out here is that the iSCSI VMK NICs have a different physical NIC failover policy because the iSCSI traffic will be leveraging the multipathing or the PSP, right. to handle its load, its availability of links, where the NFS is going to rely on the Ethernet constructs, and you want to have link failover. And so what you want to do to ensure uptime is keep your NFS traffic separate from your iSCSI traffic. Today, the way that this is accomplished in vSphere is by putting iSCSI traffic on a storage network of one and NFS traffic on a separate storage subnet, like a .2 network.
Right.
Okay.
And I think our best practices are going to converge around that very fast.
Yeah.
So to net this thing out, guys, storage HA is very critical. If you're not the storage team, it's a good idea to break bread, buy each other a beer, learn a little bit about each other's world, right? You will be leaning on each other, right? So take time to learn a little bit about the world of the other guy in both directions. And the other thing I think it's important is we're working hard as the vendor community in the storage land broadly so that more and more you don't need to be a storage expert if you're a VMware admin. And the key part of that today is vCenter plugins. If you didn't get the memo, use the vCenter plugins. So thank you very much. Very much appreciated.